Hello, this is section 2.1, part 2, finding the domain of a function algebraically. There are some important restrictions that you have to remember for the rest of this class, and we've mentioned them some while we've been doing some other work, but now it's official. So the first one you want to remember is that given a rational function, which means that if you have a variable, an unknown in the denominator, remember the denominator cannot equal 0. So for this example, you may be able to see if you put 2 in there, 2 take away 2 is 0, you would have 5 over 0, and that's not a number, right? So I call this the domain checklist. The first thing on the list is if you have a rational function and you're asked to find the domain, you just need to take the domain, the denominator. You can ignore the numerator. You take the denominator and you say, well, that can't equal 0. And then you solve for x the way you would solve any equation, and you would find out that x cannot equal 2 for this example. So your domain in interval notation, remember this means that there's a hole at 2, but everything else can be in the domain. Every other x value is going to give you a value. So in interval notation, the domain is from negative infinity to 2, union 2 to infinity. All right, the second thing on the checklist is a radical function. Now we have to make this, notice here, it's got the only radical function with even indices will give you this issue. So the index is the number that is in this little radical here, and if you don't see it, it's a 2. So if you have a square root, that's an even index. So we know that what's underneath a square root, it can be 0, but it can't be negative. So it has to be either 0 or a positive number. So what you do when you're asked to find the domain is you take what's under the radical, and you say, well, what's under the radical has to be greater than or equal to 0. So subtracting 5, you get x is greater than or equal to negative 5. And so that would be all the numbers from negative 5 to infinity are allowed in the domain. Now, sometimes I can tell when people aren't quite understanding, you're going to be asked to find the domain. That's not solving the equation. So I can tell people are trying to solve when they write things like this down. All right, that's not right. We are analyzing. We're not solving, we're analyzing the domain. We are memorizing that when you have an even index, what's under that radical has to be greater than or equal to 0. All right, now even index, what that means is if you had something like f of x equals the cube root of x, there's no restriction on that. For example, you might say, you can put a 3 and then hit the second in this radical button and take the cube root. For example, if you had cube root of negative 8, see there's a negative under that radical, you get negative 2. So that shows you that you can have negative numbers under an odd indexed radical. And so the domain of an odd index radical is all real numbers. Okay, so even index radical, it has to be greater than or equal to 0. So those are the two things you're going to be looking for. If it's a rational function, you're going to set the denominator not equal to 0. If it's a radical function with even index, you're going to set the expression under the radical greater than or equal to 0. All right, so let's put both of those together. Here's a function that has a lot going on. So you would have to cycle through both of those. And you would say, oh, is there a denominator? Yes. Well, the denominator cannot equal 0. And is there a even index radical? Yes. So what's underneath that even index radical has to be greater than or equal to 0. So x cannot be 2, and x has to be greater than or equal to negative 5. So when you get something that's a little more complicated, when you have more than one thing happening, it'd be a good idea to draw this on the number line. And so when you have two things, it's always a good idea to just go ahead and do the whole first. So x cannot equal 2 means that there's going to be a hole at 2. And then instead of shading everything, now you can shade x is greater than or equal to -5, which would be a colored circle on -5, and then everything to the right, but you know you already put the hole there, so you know to hop over it. So then the domain, which is what this graph shows you in interval notation, would be bracket -5 to 2, parentheses union 2 to infinity. Okay, so here number C is an extra one that I've just kind of recently put on here just to help students. If you have a radical function with even indices, which is right here, in the denominator, so if you've got two things happening at once, these two things combined, well, if it's in the denominator, it cannot equal 0. And if it's under a radical, it has to be greater than or equal to 0. So if you have a even index radical in the denominator, then you would set the expression under the radical greater than 0, not greater than or equal to, because it's in the denominator and it cannot equal 0. And again, you don't worry about the numerator. So if you had this function, you would just say, okay, x minus 3, it's under a radical. It has to be greater than or equal to 0, but it's in the denominator, it can't equal 0. So x minus 3 is just greater than 0. So if you add 3, you get x is greater than 3, and that's going to be, that domain is 3 to infinity. Okay, so here are a couple to try. I would pause the video and try 1 and 2, and then come back with me. All right, so number 1, did you get the first part done? The directions say to find the domain. We're not solving, we're finding what the x's can be in this function. So you have an even index radical, so what do? 7 minus 2x has to be greater than or equal to 0. Okay, now that 7 is positive, not negative. That minus goes with the 2, so we're going to subtract 7, and that's negative 2x is greater than or equal to negative 7. Then we're going to divide by negative 2. Now, you have to remember, when you have an inequality, when you divide or you multiply by a negative number, you have to switch the sign. So that greater than or equal to is going to become a less than or equal to. So when you multiply or divide by a negative number, you have to switch the sign. So that domain is all the values of x from negative infinity to positive 7/2, including 7/2. Any of those numbers can go in there and you won't get an error. All right, the second one I asked you to do, did you catch that there are 2 restrictions? Okay, the second one, did you catch that there were 2 restrictions? First thing I see in the checklist, so you've got this checklist, you just want to have it running all the time. And I write it down, and the more times I write this down, the less writing I do. So the first one is, if I have a denominator, I'm going to set the denominator not equal to 0. Second one is, if I have an even index radical, I'm going to set the expression under that radical greater than or equal to 0. And so this one is having 2 issues. So the first one, you have a denominator, so you set it not equal to 0. And you have a radical, an even index radical, so x plus 2 is greater than or equal to 0. So that gives you x cannot be 5, and x has to be greater than or equal to negative 2. So again, if you've got more than one thing going on, a number line will kind of clean it up. So I'm going to put negative 2 and 5 on my number line and put the whole on the 5 first, and then x is greater than or equal to negative 2 would be shaded to the right. So the domain in interval notation is bracket negative 2 to 5 union 5 to infinity. All right, now I wanted you to come back together for this one. So notice that you have a rational expression, you have a denominator, and notice that it is a quadratic. Well, this isn't going to change the steps. To find the domain, you have a denominator, so you're going to set the denominator not equal to 0. And we spent some time solving quadratic equations. Well, this is the same. It's still a quadratic equation. So you're going to try to solve it by factoring. So there's an x here and an x here, and the factors are 12, 1 times 12, 2 times 6, 3 times 4. And the factors that subtract to be 1 are plus 4 and minus 3. So just like before, then you would set each of these linear factors not equal to 0. And this time you get x cannot be negative 4 or x cannot be 3. Now, you can't leave it that way. You have to have your answer in interval notation. So this is where the mistakes sometimes happen. So I would suggest you draw a number line because there are 2 restrictions. But when you draw and turn it around to what is it that x can be, there are going to be 3 intervals. All right, so these are holes. So you're just going to put a hole on negative 4 and a hole on 3. And then you're going to shade everywhere else. So there's this piece that's to the left of negative 4. There's this piece that's between negative 3, negative 4 and 3. And there's this piece after 3. So when you write these 2 restrictions in interval notation, it's going to be 3 intervals, negative infinity to negative 4, union negative 4 to 3. That's the piece people miss sometimes. Union 3 to infinity. Okay. Pause the video and see if you can do the rest of these on this page. Okay. If you tried it, you've looked here, you have a radical in the denominator. So that's our checklist number 3. If you have an even index radical in the denominator, that means you're going to do greater than 0, not greater than or equal to. So x minus 5 is greater than 0. Where did this 4th root of x minus 5 go? I'm not solving that. I'm analyzing what's underneath that radical. I'm saying to myself, what's under the radical, x minus 5 has to be greater than 0. So x has to be greater than 5. So that domain is parentheses 5 to infinity. Okay. Next. Did you notice that you have an even index radical? It's not in the denominator, so x plus 2 has to be greater than or equal to 0. So x is greater than or equal to negative 2. So that's bracket negative 2 to infinity. Number 4, there's a negative outside, but it doesn't matter. Remember, if it's an even index radical, you're analyzing that. You're not going to write that down. What's underneath the radical has to be greater than or equal to 0. So that would be x is greater than or equal to 5. So that's the domain of all the numbers starting at 5 to infinity are allowed in this function. All of these x values, these are x values, you can put in here and it will give you an output. If you put 5 in, 5 take away 5 is 0. The 4th root of 0 is 0. So the 5, 0 is in that function. But if you tried to put 4 in there, 4 minus 5 is negative 1. That's not a number. That's what we mean by domain. Okay, take a look at the back of your page there, and I would say practice all of these, and then come back and check your answers, see if you did them all correctly. Okay. I just finished doing mine. You can check your answers. So for number 1, I got negative infinity, comma, negative 7/3, union negative 7/3, comma, infinity. Number 2, I had to factor, and I got negative infinity to negative 5, union negative 5 to 3, union 3 to infinity. Number 3, again, I had to factor, negative infinity to negative 1/2, union negative 1/2 to 5, union 5 to infinity. Number 4, negative infinity to negative 4/3, union negative 4/3 to negative 1, union negative 1 to infinity. And on our bottom part, you had some even index radicals for 5 and 6. So 2x plus 8 was greater than or equal to 0. I got domain negative bracket negative 4 to infinity. 6, did you do this one right? 9 minus 2x is greater than or equal to 0. Negative 2x is greater than or equal to negative 9. But you had to divide by negative 2, which means you had to switch the sign and get x is less than or equal to 9 halves. And you get negative infinity to negative 9 halves bracket, because this is what the number line looks like. All the numbers less than 9 halves. This last one was a trick one. I have an odd index, so there's no issue with an odd index. So that had a domain of negative infinity to infinity. Okay, so the last part is sometimes you have another item on your checklist, and that's real life limitations. So if you're given a word problem, nobody's going to tell you, but you have to remember that there are domain restrictions when x is something that, usually it's if x is something that can't be negative. And so you have to remember that. So for example, 8, it says the cost in dollars of producing X yards of a certain fabric is given by the function, and there's your function. So X is in yards of fabric. That's my independent variable. That's my input. And C of X is the cost in dollars. All right, now you are asked to find the domain. Okay, so the domain is the set of X coordinates. Well, the checklist says, is there a denominator? Cannot equal 0. Is there an even index radical? The expression under a radical. Even index, got to be greater than or equal to 0. Is there a combination? Radical in the denominator. That's even index, greater than 0. Well, a fourth, there's none of that. So if this were just a function that wasn't in a word problem, the domain would be all real numbers, because no, no, no. But X is yards of fabric, so you have a real world restriction that you have to remember about. And so it's just a matter of saying, okay, X can't be negative because you can't have a negative amount of yards. Now, you could have 0 yards. If you had 0 yards, your cost is $1,500. That's your initial cost. So this real world domain would be bracket 0 to infinity. All right, same thing for number 9. The surface area S of a sphere is a function of its radius given by S of R equals 4 pi r squared. Well, r is the radius. You can't have a negative radius. Now, this one is debatable, because if you said, okay, can you have a radius of 0? Well, if you have a radius of 0, you don't have a sphere. So context clue says that you have to have at least some length. So I would say that this domain wouldn't be bracket 0, but parentheses 0 to infinity. Okay, try the next one and come back and see if you got it right. Okay, so this one you had the independent variable is the variable that is here being squared times k, right? And you're told that the stopping distance varies directly as the square of the speed. So speed is your independent variable. What is the domain of this function? Well, the function, reading the context, is talking about stopping distance of a moving car. And so your speed would have to be positive. It could be 0. You could be sitting in your car. So bracket 0 to infinity. And then the dependent variable is the other variable, the stopping distance. So that's your dependent variable. All right, and then we have 4 more examples. So if you want, you can try those or not. But I'm going to pause the video and give you the answers to these as well. Okay, so here are the answers I got. Bracket 7/8 to infinity, negative infinity to 2, union 2 to 3, union 3 to 8. You had 8 minus x is greater than or equal to 0, so just switch the inequality. And then you had in the denominator, x can't be 2 and 3. Definitely advise you to graph that situation, put the holes in first, and then do the shading. Same thing here. Now, this was interesting. This is x times the square root of 3x plus 4. So x can't be 0. And what's under the radical, 3x plus 4, has to be greater than 0, not greater than or equal to, because it's in the denominator. So I got negative 4/3 to 0, union 0 to infinity. And then the last one was an odd index. So, I just realized that is not right. It is an odd, this is tricky. It's an odd index, right? So it can be a negative number or a positive number. That's true. But remember, you cannot have 0 in the bottom of the fraction. So 2x cannot equal negative 4. X cannot equal negative 2. So our domain is actually negative infinity to negative 2, union negative 2 to infinity. Did you get that? And I didn't? If you did, good job. All right, that's it for this lesson.